It says, look at the graph of 2x squared minus 4. Now, technically, how would you graph this? First, you would graph 2x squared minus 4, which would be a parabola. The absolute value would take the bottom part of that parabola and flip it up. So we get this graph that looks like a W. Now, the question is, use the graph to estimate the corresponding x values for each y value. If the y value is 4, and we'll do this one in blue, how many times on that graph is the y value 4? 3 times. There would be a solution here, here, and here. Let's double check if they actually work. It looks like minus 2. If you plug in minus 2 into this equation, what do you get? Minus 2 squared is positive 4. Times 2 would be 8. Minus 4 would be 4. What's the absolute value of 4? 4. That one works. What about 0? If you plug in 0, 0 squared is 0. Times 2 would still be 0. Minus 4 would be negative 4 inside the absolute values. What's the absolute value of negative 4? 4. It works as well. And positive 2 would work as well. Now, in green, how many solutions are there when y is equal to 9? Go to where 9 is. 9 looks like about here. 6, 7, 8, 9. There's an answer there, right? And there would also be an answer there. I mean, it's kind of hard. It's maybe 2.5, 2.6. But we wouldn't be able to say for sure. We could check. If I check 2.5, it's not quite right. If I check 2.6, it's not quite right. Our estimation is the best we could do. We're going to find out how to solve these algebraically afterwards. How many places in purple is the y value equal to 2? Oh my goodness. 4 places. 1 there, 1 there, 1 there, and 1 there. So what we're going to find in these equations and in these questions, and I'll show you an example with the blue one. What you're trying to solve is this question. In the blue one, we're trying to solve when is the absolute value of 2x squared minus 4 equal to 4? That's the question we're asking. And how do we solve when we have these absolute values? One way is what we just did. You draw the graph and look off the graph. But the problem with looking off the graph, as we saw with the green points, is that you're estimating and can't find it exact. How do you find it exact? Well, one of the things when we plugged in negative 2, 0, and 2 to check, one of the things we noticed is that what does the inside have to be? What are possibilities? If this whole thing is going to equal 4, the inside could be 2 things. The inside could be 4. If the inside's 4, would it work? Absolutely. But the inside could also be negative 4. So what we're going to find when we solve an absolute value equation is that we're going to once think it's equal to the 4, and secondly, think the inside is equal to negative 4. Now, if you solve this one, what would you do? You'd add 4 to both sides. You get 2x squared equals 8. You divide by 2 and get x squared equals 4. Then you'd square root both sides and you get plus or minus 2. Okay? And that found 2 of our solutions. But on this one over here, you move your 4 over. You'd get, divide by 2, you get x squared equals 0. This one tells you x is 0. And those were the 3 solutions. This is called an absolute value equation. And you can highlight it in your notes. Absolute value equations look like this, where there's an absolute value in the equation. We could solve it using the graph, and that's what we've done here. If you can graph the inside, and then find out where it's equal to 4, these 2 points, then you could solve it. But we're going to find that we can also solve it algebraically. But we're going to start in this part by solving the graph. So we'll go to example 1, right? And example 1 says solve by graph. So first, we're going to graph 3x minus 6 with the absolute values. How did we do that? Well, we think about the inside 3x minus 6. That would normally have 1, 2, 3, 4, 5, 6. A y-intercept at negative 6. A slope of 3, up 3 over 1. Up 3 over 1. Very important that you find that the x-intercept is at 2, 0. Up 3 over 1, up 3 over 1. This, with a dotted line that I've just drawn here, this is the straight line 3x minus 6. Y equals mx plus b has a y-intercept at 0, negative 6. But when we do the absolute value says any answer that you get, we have to make positive. So all of these answers here that were positive, I'm going to fill in with the solid line because they're going to stay the same. But the absolute value is going to take this part that's on the bottom and flip it up. So instead of having 0, negative 6, you're going to have 0, positive 6. And this is the graph of the absolute value. We're also going to graph, and I'll do this in green, y equals 6. Now, when you have a y equals line, that's just a straight line that goes across, like that. And we notice from the graphs that there are 2 places where these graphs intersect. We already highlighted one was at 0, 6. Maybe you can tell by symmetry, or maybe some mental math, that the other one is going to cross at 4, 6. So from the graph, the solution is that x is equal to 0 and x is equal to 4 is where this works. Double check it. If you plug in 4, 3 times 4, 12. Minus 6, is it equal to 6? Absolutely. Double check 0. 3 times 0 is 0. Minus 6 is negative 6, but the absolute value of negative 6 would make it positive. And that works as well. Okay, so some to try on your own. Try 5a and 6. Oh, such a good video. Completely on silent. And that's everything. It's the only volume on that whole video. Oh well.